Example 8 says if alpha and beta are the roots of x squared plus px plus q equals 0, where p and q are constants, and alpha is greater than beta, express the following in terms of p and q. It starts with alpha squared beta plus beta squared alpha. So let's look at this first. Alpha squared beta plus beta squared alpha. So we don't know what alpha or beta are yet. And specifically in these problems, we're not going to know a lot because we have these two unknowns here. They're unknown constants, the p and the q. So we are going to see if we can manipulate any of this. So one thing that you can do anytime you're factoring, if anything is in common with the terms that you have, try and take those out first. What I see is that in both terms I have an alpha. In both terms I have a beta. And so there's alpha beta. That's something that I can calculate over here. What's left here is that because I took an alpha beta away from my first term, alpha squared beta, I'm left with just a single alpha. And in the second term, if I factor out an alpha beta, I'm just left with a beta. So each of these are things that I can evaluate really quickly. So alpha beta is c over a. Well, c is q, and a is 1. So I have that. So it's q over 1, and alpha plus beta is going to be negative RB, which is P, divided by A, which is 1. So if I go ahead and simplify this, this is going to be negative PQ or negative QP, whatever you prefer. Both are the same. So this is a value, right? Just based off of what I see, just a little manipulation, I can find what I need, which is fantastic. So let's move on here. Okay, so I'm looking for alpha minus beta now. Okay, so I have alpha minus beta. So what I know off the bat is that if I need to find alpha minus beta. I know what alpha plus beta is, but not this. So what I'm going to do is I'm going to say, okay, well, remember this from before, alpha minus beta squared, okay, which is not what I need, but we're going to use this to start. Alpha minus beta squared is going to be alpha squared minus 2 alpha beta plus beta squared. Okay, so I've got alpha squared minus 2 alpha beta plus beta squared. So from this point, what I need to see is I need to try and find a way to get this into a form that I need. So I don't know what these are. I have to somehow figure out a way to express this alpha squared and beta squared in terms of something that I know. Well, what I do know is that alpha plus beta squared equals, okay, alpha plus beta squared is going to equal alpha squared plus 2 alpha beta plus beta squared. Okay, so I know this and I know this, and so again, if I move all of those things to the same side, it may make sense on how I have to go and handle this. So if I know that I can say, okay, well, alpha plus beta, that squared, minus 2 alpha beta equals alpha squared, oops, let me clean that up a little, alpha squared plus beta squared. So I can go and actually replace that with what I had before. So if I go back and replace this stuff, what I'm going to have ultimately is I'm going to have, not only an alpha plus beta squared. Alright, I'm going to have my minus 2ab. So that's this line here. And then obviously I need to account for this as well. So I got another minus alpha 2ab. So this is a lot of kind of manipulating, but kind of understanding how these different squares work can really help you understand where things come from, what something looks like in the future. So what I'm going to see here is that alpha minus beta squared. Okay, that is what we just wrote, which is alpha plus beta squared minus 4 alpha beta. So I know that and that. I can plug those in. It won't be a big problem. But remember, I'm looking for alpha minus beta, right? So ultimately what I have to do in order to get down there, I'm going to have to take the square root. So I know that I'm going to get alpha minus beta, okay, is just going to equal the square root of this thing that I saw before. And I know this is a challenging problem, but follow these notes in case you need it on the next stuff. So what I have now, if I plug in my knowns, so alpha plus beta, what I found as alpha plus beta before was negative p over 1, or negative p. So this is negative p squared, and I'm subtracting for ab, so alpha plus beta, is q, so it's minus 4 q's. And so if I go ahead and simplify this, I'm going to be left with negative p squared, just makes p squared, and I subtract away 4q. So this is pretty intense as far as algebraic manipulation, but we basically use the concepts of the difference of two numbers squared versus the sum of two numbers squared, and we manipulated them to make them fit